progeny have different characters than parents.
Than parents. Or we can say that genes are segregating from generation to generation in different ratio,
Yeah.
isn't it? But eh, in case of back cross, what was our ratio? It was 1:1. In case of F2, if I see, that ratio is 3:1, 3:1 of gametes. Gametes are segregating to each other. That was the law of segregation. So gametes are segregating to each other in particular ratios. But sometimes due to some reason, these gametes are not segregating in this expected ratio. And this phenomena is known as disturbed segregation. This
EP
phenomenon.
status is there.
Yes, what?
EP status is there.
I didn't get you. What are you telling?
EP status is condition when desired ratio is not gained by the
Yes,
gene.
they all these conditions are genetic, means we can say that there is some genetical modifications are there, just like duplications of gene. If you have
Yeah, yes, sir. Yes, sir.
epistasis is there,
Yes, sir.
like in suppose in epistasis the ratio is 9:7. Likewise, different 15:1 is in duplicate gene. So they will segregate in different ratio as per without our expected. So suppose this is expected ratios are there, but it will, and 1:2, 2:1 is also one ratio. So this will not segregate in our expected ratio. Then this is known as, this phenomena is known as disturbed segregation. So I can write the definition that factors are not, or gametes are not segregating, factors are not segregating in the expected ratio due to some reason. And that reason will be purely genetical due to some reason. Okay, so in back cross, I've told you that this will 1:1. So, like in case of F2, this will not segregate as 3:1. Same, VV is not segregate is to 3:1. Then this will be the case of disturbed segregation. Now, if you remember, what was the formula of chi-square linkage in case of F2? A1 minus 3A2, remember, minus 3A3 plus 9A4 to the power 2 upon 9n. So that was the formula of chi-square linkage in case of our chi-square linkage. Means generally whenever we want to find this chi-square L linkage, we will use this formula. Just, and the ratio was 3:1. But in case of disturbed segregation, I'll tell you the generalized formula. Suppose A is segregating in L1 to 1 and BB is segregating into L2:1 ratio. Okay, then chi-square L will be A1 minus L2 A2 minus L1 A3 plus L1 L2 A4 whole square upon L1 L2 N. Okay, now suppose there is no disturbed segregation, no disturbance is there, then A will segregate in 3:1 ratio, then BB will segregate in 3:1 ratio. So our L1 is equal to 3, L2 is equal to 3. L1 is equal to 3, L2 is equal to 3. Now see, if I put the values over here, so chi square L will be A1 minus L2 is what? 3. A2 minus L1 is what? 3. A3 minus L1 into L2 is 9. A4 plus upon L1 L2, that is 9n square. Okay. So this is generalized formula of chi-square linkage, chi-square L in case of L1 L2. Now suppose there is disturbed segregation. Then A is segregating in 3 is to 1 ratio and BB is segregating 15 is to 1. That is, we know that that is in case of duplicate gene. Just let me cross check this. This is the duplicate gene case. That is duplicate gene. Okay, that is duplicate gene interaction. So this 15 is to 1 will be there. So our actual ratio was 9 is to 3 is to 3 is to 1. This 9 3 3 will be same, and we will consider it 15 is to 1. These all will be duplicates due to some reason. So this is our, now this is ratio is changed. So this will be our segregating ratio due to duplicate gene interaction. So now what is L1 is 3, L2 is 15. Now we will put this value into chi square L and we will get the chi-square linkage, and if it is significant then we will say that there is a evidence of linkage. Okay, समझ में आया? Is there any doubt? Just like different ratios are there, 9 is to 7 is one other ratio. Likewise, different ratios are there. In case of duplicate gene interaction, in case of epistatis, like, so there are different cases of gene interaction are there. You can find it in any or you can find it in Google. So likewise, different cases are there. So we can find this chi-square linkage in case of disturbed segregation. Okay. Now, one important result is, now we will use again different methods of estimation of this chi-square linkage of method of estimation in case of disturbed segregation. So it is has been found that that method, that product ratio method is more efficient method of estimation of linkage in case of disturbed segregation. Okay, so this is very much important, that in question it can be asked that which method is more efficient in case of more efficient of estimation of linkage in case of disturbed segregation. So the answer is product ratio method. So again, for disturbed segregation we will see that all the 5 methods, and we will find the variance of all this, and we will see that this product ratio method is giving giving us less variance. So less variability is there, then we can say that is more efficient. Okay, got it? With this we have completed our Mendelian genetics. Now if you have any doubt, you can ask me. So there in statistical genetics there are three parts. One is Mendelian genetics, one is population genetics, and one is advanced genetics. So we have completed our first part, that is Mendelian genetics. I hope you guys understand something. Is there any doubt? Okay, then we will move to the.
सर वो ग्राफ का थर्ड पॉइंट एक बार फिर से एक्सप्लेन कर दीजिए ना.
Okay, just let third result.
यस सर, थर्ड पॉइंट वाला
This
रिजल्ट.
at p is equal to zero point 0.5, complete dominance has only 4 by 9 information as back cross.
यस
See,
सर.
see here, at p is equal to zero point 0.5, this is the line of complete dominance. So see, at zero point 0.5, this is here. Okay, this is, and at this side, what is this information? So we can say at p is equal to zero point 0.5, f2 complete dominance is providing how much information? It is less than zero point 0.5. So it is near, means near about zero point 0.4. So the exact amount is 4 by 9. So 4 by 9 of back cross. अब back cross का कितना information we are considering? 1. So 4 by 9 is what? 0.44. So this is up. Now suppose I am taking that back cross is providing 100% information. So as compared to back cross, this will provide 44% information in case of p is equal to zero point 0.5. Okay.
यस सर.
Okay then. Any other any other question?
सर कंप्लीट क्लासिफिकेशन एंड इनकम्प्लीट क्लासिफिकेशन में डिफरेंस थोड़ा बता दीजिए.
I told you na difference, that if we are considering, see, complete classification, we are considering coupling and repulsion phase also. So there will be total 10 genotypes, 10 type of genotype, because we have bifurcated our this part. See here, just a minute. We have bifurcated our this AABB type. There are four. This type genotypes are four, but we have bifurcated into it in case of in coupling and in repulsion. So this is its coupling case. So two will be in coupling and two will be in repulsion. So we have make two different classes, but in its representation will be same as AABB. But if we see in chromosomal form, then we will see the difference in coupling and repulsion. So this will be two classes of this, two classes of this. Okay, then we have made two another type of genotypes, that is coupling for and repulsion. That's why there are 10 genotypes here are there. 1 2 3 4 5 AABB for coupling, AABB for repulsion. But in case of incomplete classification, here we will not consider coupling and repulsion case. So see, one, this type will be here, 2 3 4 5, this will same. This will be 5 6 7 8 and 9. So there will be 9 type of genotypes will be there in case of incomplete classification. Now what is now incomplete dominance? See, if this is the case AABB, then this will and this will, so suppose I am making this cross AABB, sorry, suppose I am making this cross, then our progeny is this, or I am making this cross. So this will be Just a minute. Or I am making A cross A, then this will be small a, capital A, small a. Then we will cross it. Suppose selfing I am done, I am doing selfing, then capital A, capital A, capital A, small a, small a, small a. So this will be in 1 is to 2 is to 1 ratio. But if there is a complete dominance, so complete dominance, so this will be of red color, this will be of white color. I told you in Mendelian principles. Now, if there is incomplete dominance, so this type will be of different color. Pink flowers will be there. So, if we consider here this phenomena, then we will get different information value, and by using that information value, that they have created this graph, and on the basis of this graph we have find different results. Okay,